Alright, hello 7th graders, welcome back. Today we're going to talk about the vocabulary that came out of lesson 2. We're going to talk about a few key concepts that showed up there. Whoops, wrong thing. That's the other video uploading. Alright, so the first thing that we run into is something called seismic wave. Seismic wave. Remember, we did that activity with the tins, and in the tins were different objects. So here's my terrible picture of tins, and we're going to use our X-ray vision to see what's inside. And inside the tin we had a rock, if you guys remember. And when you shook it, the rock bounced around and it hit it and jostled it. And as your guys' hands were on top of it, you could feel the rock and you could feel the weight of the rock hitting it. You could hear it. So there's different little techniques that you use to identify that there was a rock in there. Now another one that people had was, in another tin we had a crushed up paper ball. And this crushed up paper ball, when it moved, it didn't have as much weight as the rock. It also had a different sound than the rock did. So using those clues, actually a few of the people had figured out that this was indeed a paper ball. And so what happened was we used all these different clues to figure out what's inside here. Now again, remember I asked, how deep have we ever gone into the earth? So here's the earth. And it is ridiculous. Yep, pretty much nowhere into the earth. But we know what exists on the inside. The reason we can know what exists on the inside is because of seismic waves, because as waves travel through the earth, so you have an earthquake, when it hits different materials, like say there's different material here, it's going to do what you see on page 11. It's going to split around it, and the wave is going to change. And actually, knowing how rocks react to energy being put through them, you can actually map out how big the rock is, what its formation is, and what kind it is. Oh, sorry, page 11. So on page 11, you can see how the seismic wave works. Now, because we can use seismic waves, we can then look into the earth. And as we look into the earth, the first layer, so say here is a cutaway diagram of the earth. So the first layer we're going to run into is called the what? The crust. Just think of it like you're eating into a pizza. The crust, the first thing you're going to run into. Now the crust on the continental part, and so think of it as the land part, is going to consist mainly of granite. Now when you're dealing with the water, so like let's say it dips down and here's the water, whoops, here's the water, you're going to be dealing mainly with basalt. Whoops. So basalt and granite are the two things that you're going to be dealing with on the crust. And remember, basalt is with the water and granite is with the land. Now, once we get down past the crust, we're going to run into something called the mantle. So let's draw that cutaway earth again. So there's the crust. So there's this. The crust is actually even thinner than that. You have the crust. There's the core. So this is the mantle. Now the mantle is divided up into 3 sections. You have and all of these will make it sound like you have a lisp. So here's the 3 sections. So this first one is called the lithosphere. The next one is called, and this is where the lisp really kicks in, asthenosphere. And the very last layer is known as the mesosphere. So here's your 3 layers. And as we pass through, we're going to run into the core. So there's our Earth. And you have the outer core and the inner core. So that's pretty easy to remember. So the core is divided into 2 parts. You have the outer core and the inner core. And if you turn with me to page 15, we can see the outer core is a layer, so it says the outer and the inner core. It's the second paragraph down. The outer core is a layer of molten metal surrounding the inner core. Despite enormous pressure, the outer core is liquid. The inner core is a dense ball of solid metal. The inner core, extreme pressure, squeezes the atoms of iron and nickel so much that they cannot spread out to become a liquid. So right here, you get it as a liquid. Right here, you get it as a solid. All right, so one of the words they talked in there, and you guys are probably pretty familiar with because we learned about it in the water lesson, is pressure. So here's Earth. Remember I drew the arrow? The more you get inside Earth, you're going to get more pressure. So I'll call it the pressure diagram. So this is more, this is less. So the more pressure you get, or the deeper you get, you're going to get more pressure. The higher up, the less you're going to have. Think of it, it's the same way as water. As you dive down deep, you can actually feel the effects of pressure on your ears, and it starts to hurt. That's because you're having more pressure pressing on the inside of your ears than if you're on the surface. Now, along with more pressure, as you get closer, pressure equals heat. The more pressure you have, the more heat you're going to have. So the further you go inside Earth, the more heat you're going to have. The way this works is because we talked about in class, everything is made up of atoms. And atoms are never just standing still. Atoms are constantly moving. When you sit there, they're going to be vibrating, they're going to be moving a little bit. So these are all the little moving lines. Now right here, they're spread out enough so as they're moving, they're not really touching each other. So the best way to think of this is take your hands. So I'm trying to draw hands. There's oh my gosh, I'm not even going to try to draw their hand. So you take your hands, oh I guess I do have to, and go like this. Take your hands, and don't rub them together, but move your hands back and forth really quickly, about an inch apart. Now, do your hands change any temperature? That you're moving them an inch apart? Not really. But, like atoms, if you put them inside a space, so instead of a space that big, we give them a space, let's do it. We give them a space this big. Now all the atoms are now pushed together, and as they vibrate, they're a lot closer, and they're knocking into each other. The same thing happens with your hands. Now take away that inch and put them together and rub them together, and you get something called friction. And this friction is going to build up heat. The same thing's happening in the Earth's core. As all of the things push together, once you get down inside the core, you're going to get a lot of heat, a massive amount, because everything's crushing all those atoms together. Alright, does that make sense? I sure hope so. You can look through the book, and it describes some of the concepts a little bit more in different ways than maybe I did. So if you have any questions, again, feel free to email me at bmiles@somersetnlv.org. Don't put com, but put org. All right, and leave any questions, comments, or suggestions on there. All right, well, thank you guys so much. Take care. Have a great night.